Hello, everyone. All right, so we're going to do something a little bit different today. Still in our equation unit, but it's going to look a little bit different. So the name of our lesson is Writing Equations in Two Variables Notes. So we all know what variables are. They can be x, y, length, width, height, etc. An equation in two variables represents, make this just a little bit bigger, represents two quantities. So a quantity is an amount of something or a number. Two quantities that change in relationship to one another. An equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables is an ordered pair. So that term should sound familiar from our graphing unit. Ordered pair that makes the equation true. All right, so let's take a look at this question. Is this point a solution to the equation? And then it says prove algebraically. All right, so we are going to focus on this information right here. Remember, when you have variables, the first variable, when you have an ordered pair, the first term is your x and the second term is your y. Well, if y is equal to 6, we're going to substitute. So first I'm going to rewrite my equation, y equals 2x. Now I'm going to substitute. I'm going to put my 6 in place of y equals 2 times x. I'm going to put my 3 in place of x. 2 times 3 is 6. And 6 equals 6. So your final answer would be yes. So we're going to focus on y is equal to 4x minus 3. Remember to always label your terms. First is x, second is y. So I'm going to rewrite my equation, y equals 4x minus 3, and then I'm going to see if that's true. So I'm going to take my value of y, which is 12, and substitute it in. So if y equals 12, is that equal to 4 times x if x equals 4 minus 3? So now we're going to do the math. 4 times 4 is 16. 16 minus 3 is 13. 12 does not equal 13. So that answer would be no. The variable representing the quantity that can change freely is the independent variable. The other variable is called the dependent. Variable, because its value depends on the independent variable. Because its value depends on the independent variable. So the independent one is the one that can change. The dependent depends on the independent. Sounds a little confusing, but we're going to do some practice. Write the formula for the following. Tell what each variable represents and try to identify which variable depends on which. So we're going to focus on this first question. The area of a rectangle with a length of 5 centimeters. So it's asking for the formula. Well, we know to find the area of a rectangle is length times width. Well, I was given the length right here in the statement. So now I can substitute 5 for the length, but I still don't know the width. Now the question is, does the area depend on what the width is? Or does the width depend on what the area is? In order to calculate the area, we would have to know the width. So the width, so the width is the independent variable, and the dependent is the area, because the area of the rectangle depends on what the width is. The area of a triangle with a base of 8 inches. So we all remember to find the area of a triangle is 1/2 times base times height. Well, I'm told right here the base equals 8 inches. So I can substitute 1/2 times 8 times the unknown height. So in this case, the area of the triangle depends on the dimension of the height. So the height would be the independent, and again, the area would be the dependent. I think you see a little pattern starting here. The area of a rectangular classroom floor with a length of 25 and a width of W. So if this is a rectangle, we're going to use the same formula we always have. Area equals length times width. And then we can substitute 25 for the length, but we still don't know the width. However, in order to calculate for the area, we would have to know what the width is. So the width is something that can change, but the area is dependent upon what the width of that classroom is. Remember, you can always pause if I'm going too fast. You can rewind, etc. if you need to go back. What about this? The equation T equals 15P plus 15 gives the total cost, T in dollars, of a meal with a tip of P%. Now notice what it says here in decimal form. So the formula, we're going to write this equation that was given above, right up here. Oops. So we're going to copy this down here.
Good afternoon.
That T is equal to 15 times P plus 15.
There's no after-school tutoring today or late bus.
So the total amount is dependent upon the percent tip. The total amount of your bill would depend on how much you choose to tip your server. Independent variable, dependent variable. So we're going to look at the speed that you are driving a car. What does that depend on? The speed that you are driving a car. So what's dependent upon that? How quickly you arrive. How quickly you can get from your house to the store depends on the speed of your car. What about the number of hours that you sleep before a test? What is dependent upon that? So we've talked a lot about this year. How you score on a test or how you're performing in class is often dependent upon how much sleep you got the night before. If you get very little sleep, that would result in probably not performing very well. If you got a very good night's sleep, you would probably perform much better. So the last one here says, the amount of money that you earn at your job is dependent upon the number of hours that you work. So when your boss comes to Friday to calculate your salary for the week, they're going to calculate the number of hours that you work. So the amount of money that you get paid depends on how many hours that you chose to work. All right, last problem. We got a lot going on here, so pay close attention. Lots of information. A pepperoni pizza costs $6. Additional toppings cost $1.50 each. Write and graph an equation in two variables that represents the total cost of a pizza. Begin by filling in the chart. Okay, let's go back and reread. A pepperoni pizza costs $6. Additional toppings cost $1.50 each. Write and graph an equation in two variables that represents the total cost of a pizza. Begin by filling in the chart. All right, so let's look over here. Look in the left-hand column. That says the number of toppings. If you have 0 toppings and you're only ordering the pizza with just the pepperoni, then the math problem would be $0 extra for toppings plus the $6 flat fee for the pepperoni pizza, so you would only owe the $6. But what if you love mushrooms? Maybe you want pepperoni and mushrooms. So then you would owe the $6 for the pizza plus $1.50 for one extra topping. So then you would owe $7.50 for your pizza. What if you want the pepperoni that's included in the $6, but you want mushrooms and green peppers? You're going to owe $6 for the pepperoni pizza plus $3 for 2 extra toppings. So you would owe $9 for your pizza. What if you want 3 extra toppings? You would owe $6 for the pepperoni pizza. Now, if you're not sure what $1.50, it's $1.50 per item. So $1.50 times 3 extra items would be an extra $4.50. So then you would owe $10.50 total for your pizza. What if you're going to get really wild and crazy and you want 4 extra toppings? Well, what's $1.50 times 4? $6 extra. So $6 for the pepperoni pizza plus another $6 for your 4 extra toppings. That would be a $12 pizza. All right, so look carefully at what these are labeled in here. See how this says X and this says Y? Those are going to be our ordered pairs when we go to graph. So I'm going to erase the math that I did down here. And what I'm going to do is I'm going to take my 0 toppings and my $6 cost and turn that into my first ordered pair. If I get 1 topping, I owe $7.50. So if X equals 1 and Y equals 7.5, where would that fall in the graph? If I get 2 toppings, that would cost $9. If I get 3 toppings, that would cost me $10.50. And getting wild and crazy, 4 toppings, I would owe $12 for my pizza. All right, so now we're going to graph. So we all remember this is the X over here, and this is our Y. So if I'm going to look at my first ordered pair at 0, 6, I'm going to go to 0 on the X. I'm going to stay right there at my origin, and I'm going to go straight up to 6. 1 and $7.50. I'm going to go over to 1 on the X and up to 7.5 on my Y. 2 toppings, 2 on the X, cost $9, 9 on the Y. 3 toppings, move over to 3 on the X, would be $10.50, go up to $10.50 on your Y. Or 4 toppings would cost $12, so right to 4 and up to 12. Notice how all of these points fall in a line. If your points fall in a line, you should always connect those like that. All right, so the last thing we need to do is label our graph. So we're going to put pizza, total cost for our title. That's what this graph is showing. Now, for your X, what are we going to label this down here? We're going to label it exactly what it was called over here, number of toppings. Look at what we called Y. Y is cost. So over here, we're going to label our Y-axis cost. Alrighty, that's all, folks.